Now, sample design is very important in any research, because researchers usually draw conclusions about large groups by taking a sample. Suppose you want to find out the strength of bricks. So there is one truckload of brick which has come to the site. Obviously, one cannot test all the bricks. So only a predetermined number of bricks are tested. Suppose you test 20 bricks, and then you say that the compressive strength of these bricks is, say, 11 Newton per mm square. So based on the analysis of the sample, we arrive at the conclusions about the population. The population doesn't mean living beings. Population is basically all items under consideration in any field of inquiry. So all the bricks that were there in the truckload, there could be 10,000 bricks. Those bricks, they form a population. So this is a population of bricks. Out of those bricks, we have taken a subset. We have taken 20 bricks and tested them. So these 20 bricks, it constitute a sample. A sample is a segment of the population selected to represent the population as a whole. Population here does not mean living beings. It could be living beings also, but it could be non-living beings also. Ideally, that sample should be representative and allow the researcher to make accurate estimates of the thoughts and behavior of the larger population. Now, sample design is very important. I can give you a very practical example. In exit polls, sample size is first taken. So in a constituency, suppose a survey is being conducted on an exit poll is being conducted in a Vidhan Sabha constituency, for example. So the population is 5 lakhs, and there are 5 different types of groups of people. For example, they could be general category, minorities, scheduled caste, scheduled tribes, OBC, like this. So there are 5 groups. So if the population is 5 lakhs, and if you are interviewing, say, 50,000 people, suppose, then 10,000 from each group should be there. So then only we can arrive at, because you cannot have one group of people and base your opinion on those group of people. That is the reason sometimes if the sample size is not proper and the sample design is not proper, then the results of the exit polls can be erroneous also. We have seen this in the past. In our country, it happens all the time that the exit polls go just are just erroneous, and they give the opposite result of what actually happens on the counting day. So sample should be representative and allow the researcher to make accurate estimates of the thoughts and behavior of the larger population. Now, in the case of bricks, again the sample has to be representative. So you cannot take just 20 bricks from one place. You have to take different bricks for different place. So this process is called randomization. So randomization is carried out. So this is when we discuss sample design in the in detail, then all these things, how to calculate the number of samples, how to calculate the how to decide the representation of different groups, that is all discussed there. Now, once we have decided on the sample size and the sample design, the next step is to collect the data. So primary data is one which is collected through experiments or through surveys. And once you have calculated the primary data, you can do some sort of analysis, preliminary analysis, and that data becomes the secondary data. A primary data on the researcher who has collected it may become secondary when it is given to some other researcher or after a considerable editing has been done. So truth of the hypothesis can be examined with the help of data collected through experiments. As I've already told you, hypothesis testing is something, there are a few chapters in research methodology on hypothesis testing. So we have to test the hypothesis based on what kind of data we have, what is the distribution of the data. So if the distribution of the data is normal, then we have to use some Z distribution. If the distribution is not normal, then we could use T statistics. So depending upon what kind of data is available, the truth of hypothesis can be examined, and we can come to some conclusion whether we can accept this hypothesis or we have to reject the hypothesis. And also some probability of error is associated with this type of rejection or acceptance of the hypothesis. So most computational research works require historical or observed data for analysis and simulation purposes. So observed data is something like, for example, rainfall stations are there. Like India Meteorological Department has rainfall stations at different places in India. So they collect rainfall. Whenever rain takes place, they collect the amount of rainfall and then they report it in terms of depth of rainfall. So you must have heard that the rainfall today was 40 mm or 30 mm. So rainfall is always expressed in terms of the depth. So this type of data is the is observed data, and this data is observed for many years, and then when we retrieve it, extract it or receive it from some agency, we call it as historical data. Suppose we could have data for 50 years of rainfall from IMD, then it is a historical data of rainfall. Now there are surveys also. So in surveys, we can obtain data from in different ways. One is just by observation, through personal interviews. So actually, this concept of personal interviews involve the enumerator or the data collector or the surveyor going to the respondent and collecting the information from. Then there are telephonic interviews. These telephonic interviews are very common in Western countries. In England, for example, they are very common. So the enumerator or the surveyor would call on telephone line, and then they speak to people, and in return they also give them some incentives. Like if you can speak to me for 15 minutes on a particular topic, and then we can send you some coupons which will give you some discount at supermarkets. So this type of incentives are also given to people. So that is how people are lured into giving their 15 minutes of time to them. Another method is by mailing of questionnaires. So you can mail the questionnaires. Earlier, the questionnaires were mailed through posts. Nowadays, the mailing of questionnaires takes place through email. So you might be receiving questionnaires from people. Okay. Now, then there are schedules also. Now, schedule is different from a questionnaire. In a questionnaire, there is a question and a set of answers. So basically, it's like an objective type question. Like, what is your annual income? Between 10,000, 20,000 to 50,000, 50,000 to 5 lakhs, 5 lakhs to 10 lakhs, 10 lakhs and above. So the respondent has to choose one value, take one value. But in schedules, they are much more open in nature. So in schedule, a question is given, what do you think about the Swachh Bharat Abhiyan? So the respondent can write his feelings, his thoughts in the schedules. So schedules are much more open in nature than the questionnaire. So schedules can be filled by the enumerators, and this type of schedules have some advantage that even an illiterate person can also be considered as a respondent. So once the data has been collected, the next step is the processing and analysis of the data. So the first step is to see that the data that you have collected is free from errors. So the best way is to plot the data plot it on an Excel sheet, for example. So suppose you have rainfall data for 50 years, you plot it, and there could be some value which is 50, but erroneously it has been written down as 500. So when you look at the graph, automatically you will come to know that there is a spike in the graph, and you can obviously just eliminate that value from your data set. So processing and analysis of data involves a number of closely related operations. Most important is the editing. So examine the collected raw data to detect errors and omissions and correct them as far as possible. So that is what we mean by editing the data. Then next step is the tabulation of the data. So you can tabulate the data, and the tabulation can be simple or it can be complex tabulation. So if there are only two sets of data, it's very easy to look at the relationship between two sets of data. But if there are large number of variables and cross correlation is required, then you will have to have one column and there are number of rows. Now, analysis of data can be carried out using various tools. Nowadays, there are tools that are available free of cost. For example, R package. It's a very good tool. It is available free of cost, and it is a good tool that can be used for statistical analysis of the data. MS Excel, everybody knows MS Excel. MS Excel can be used for many things, including for optimization problems. Now there are certain add-in programs which are there. For example, there is an add-in program called Solver. So somebody who is doing some optimization can also look at Excel. There is an option to carry out optimization in an Excel spreadsheet. SPSS is a very popular statistical analysis tool. Then there is MATLAB. MATLAB is really good when you want to deal with large number of matrices. For example, finite element method. Those who are from civil or mechanical engineering, they would know that finite element method requires processing of matrices of large sizes, basically. So there could be a matrix of 16 by 16 size. You have to multiply it by say 16 by 8 size matrix. So that matrix multiplication can be very easily done in MATLAB. R package, I have already told you, it's a open source software. If you just type R package, you should be able to install it. And then there are different different libraries that are there. So those libraries can be installed, and you can do different types of works. So if you want to do, for example, graph plotting of graphs, there is a library ggplot. You download that library. Then we have Python scripts. Nowadays it has become very easy. You can go to ChatGPT, write, I want a Python script to carry out an analysis. I want to conduct a chi-square test on this data. So that is a very useful method. It will give you a Python script. You can run that Python script. But some knowledge of Python is in fact required. So many artificial intelligence models, they are built on Python. So all AI models, they use Python in one sense or the other. For example, artificial neural networks, random forest, all these techniques, they are using Python scripts, and these Python scripts can be easily generated using these natural language processing models like ChatGPT. Now, I've heard that even another version, another large language model has been developed by Elon Musk and his team, and they are going to unveil it very soon, maybe in a day or two. And